What's going on, guys? My name is Matt and I am back with a new PC build. This time the price point is $750, and given the current market, it's providing a good amount of performance for that price. This video is going to be a full build guide. I'm not only going to show you each of the parts and why I picked them, but I'm also going to be showing you how to put everything together step by step, and then finally I'm going to be showing you gaming and streaming benchmarks. This PC uses all new parts with the exception of the graphics card. While there are obviously tons of different ways you could have spent this budget, I went with parts I know are quality, that'll work well together, and will last you for a long time. So the first thing I usually select with the system is the CPU. This determines a number of other factors for the build, and other than the GPU, this has the biggest impact on gaming performance. At the time of pricing this build out, the Ryzen 5 5600G is, in my opinion, the best mid-range CPU available, and at $240 it fits nicely into the budget. For $240 you're getting a slightly downclocked 5600X but with the inclusion of Vega 7 graphics. The 5600G is a 6-core 12-thread CPU running on the latest Zen 3 architecture. It has a base and boost clock of 3.9 and 4.4 GHz respectively. These are pretty good speeds, but what's cool is the CPU, like all Ryzen chips, is overclockable, and I'll be showing you some BIOS tweaks to squeeze even more performance out of this already amazing CPU. 6 cores and 12 threads is more than enough for gaming, and is even good enough for streaming and basic video editing. One other thing I really like about this CPU is the fact it comes with a pretty decent cooler in the box. The 5600G comes with the very basic Wraith Stealth cooler, but for stock performance or even a mild overclock, this guy gets the job done well. I think it looks good, certainly better than the Intel stock coolers, and overall for $399 you can't go wrong with using a stock AMD cooler, especially when you're on a budget like we are. If you're worried or interested at all about temps, then you'll be able to see in the benchmark section exactly how this system runs temperature wise. In terms of the motherboard, this is an area where a lot of attention needed to be paid. Being a new CPU, the 5600G has limited compatibility with even newer chipsets like B550 and X570. When picking out this board, I wanted something that was under $100, offered a lot of features, and would be guaranteed to work with the 5600G. With my criteria set, I ended up going for the Gigabyte B550M DS3H. This is a $90 board, and I use the version with Wi-Fi, which costs about $10 more. This motherboard features 4 DIMM slots, multiple M.2 slots, a decent VRM setup, and a nice neutral color scheme. Now my board came with a BIOS that was over a year old, and it's still posted with the 5600G. This is unlike the ASRock B550M Pro 4 I recently purchased, and even if for some reason your board comes with a really old BIOS, you can use the QFlash feature to update the BIOS without even needing a CPU or RAM installed in the board. The back panel I/O is pretty good, and overall, I think this is the best option out right now for people wanting to build a budget 5600G system. Moving on to the RAM, I went for the cheapest 16GB kit I could find that still offered decent specs. What I ended up going for is this 2x8GB kit of silicon powered DDR4 RAM. This kit is rated to run at 3200 MHz CL16 for only $50. This is a really good value. If this was going to be just an APU build with no dedicated GPU, then I would have went for a 3600 MHz kit, but because we are using a dedicated graphics card, getting super fast RAM isn't as important. 16GB is more than enough for modern gaming and is even enough for streaming and 1080p video editing. What's also nice is this kit only takes up 2 of the 4 DIMM slots, meaning upgrading to 32GB in the future will be as easy as popping in another 16GB kit. Right now, decent quality RAM is really affordable, so only having to spend $50 of the budget on this kit means we can allocate more of the budget to other parts of the build. Moving on to storage, I knew I wanted an SSD and preferably an M.2 drive. After looking at a bunch of different drives, I settled on the Western Digital SM550. This is a 500GB NVMe drive in the ultra compact M.2 form factor. For only $43, this drive offers an insane amount of value. It doesn't have VRAM, but for a budget boot drive, this works more than okay. 500GB is enough for your OS, applications, and a modest games library. With that being said, if you run out of space, adding more storage is one of the easiest upgrades you can do, which could come in the form of another SSD or a large mechanical drive for mass storage. With that being said, if you have the budget, you could always spend the extra $44 and get the 1TB version of this drive for more storage out of the gate, and I'll have both versions of this drive linked in the description below. Now let's talk about the graphics card, which is obviously a big place where focus needs to be paid. You probably already know this, but if not, GPUs right now are ridiculously expensive due to supply chain issues, crypto miners, and scalpers. To get the most performance possible, we need to get a used graphics card. The graphics card I ended up getting was an R9 390 for around $215. Unfortunately, prices have jumped a bit since purchasing this card, so if you can't find an R9 390 for a good price, then going for an R9 290 or GTX 970 is going to give you very comparable performance, and you should be able to find one of those for at or slightly above the $200 price point. Any of these cards are going to give you great 1080p gaming performance, which you'll see in the benchmark section. You can look for these locally, but buying through a site like eBay means you will have buyer protection. While I do recommend the R9 390, I don't necessarily recommend this particular model for this build. This is the Sapphire Nitro variant of the 390, and because of how long it is, it barely fits. With that being said, as long as your 390, 290, or 970 is at least a little under 300mm, then you're going to be fine. I'm going to have links to all these cards in the description, so make sure to check them out to find the best price possible. Obviously, buying a used card isn't ideal, but right now it's what must be done to build a system in this budget, and any of these cards will work great as a placeholder while you wait for GPU pricing to return to normal. Moving on to the power supply, I knew I needed something with a good amount of wattage, as the R9 390 is a pretty power hungry card. The unit I went with is the EVGA 650BQ. At the time of making this power supply is going for only $50 on Newegg, which is an insane value in my opinion. 650 watts is more than enough for this system. With an 80+ bronze rating and it coming from a reputable manufacturer like EVGA, I have no problem recommending this unit. It is all black sleeve cables and a semi-modular design, meaning we only have to put in the cables we need and don't have to clutter our case with cables that we don't. Overall, this power supply worked great in this build and I can highly recommend it. The last thing to talk about is the case. I went for one from a brand I haven't tried in the past and am pleasantly surprised at the features, value, and quality it's offering. This is the Motherboard TW7. It's in the micro ATX form factor and I think it's a good value at the current going rate of $65. It has two included ARGB fans with a built-in controller, a mesh front panel, power supply basement, and one of the coolest things is the side panel. This tempered glass panel is actually magnetic and on hinges. You just swing it open and lift it away, which is super convenient and not something you normally see on a case at this price point. This is a pretty compact case, even taking into consideration the micro ATX form factor, so if you are looking to build a space efficient system, then I would definitely check this out. This is not the easiest case I've ever built in, but it's not bad at all and is still beginner friendly. All in all, for $500, you're getting a set of quality parts that will last you a long time and allow you to do a ton of different stuff on your PC, from gaming to streaming to even video editing. So now that you've seen each of the parts and learned about why I picked them, I'm now going to show you how to put everything together. There are a number of ways and orders to assemble a system, but I'll go over my preferred method. Before you get building, it's important to make sure you're ready by grabbing the right tools and having an open area to work on. The only thing you really need is a standard Phillips head screwdriver, a smaller Phillips head screwdriver for the M.2 screw, and you might need a pair of pliers. I would highly recommend you use a magnetic screwdriver. This will make building the PC a little bit easier and can be helpful in a number of ways. With your workspace ready to go, your schedule clear, and your tools in hand, it's now time to start building your PC. The first thing to get out is your motherboard and set it onto its box. Bring your attention to the center of the motherboard where the CPU socket is, and press down and out and then pull up on this metal retention arm until it's perpendicular to the board. Now get your CPU out and bring it to the socket, handling it only by the edges. Line up the 5600G model name with the socket AM4 text on the board, or line the small triangle on the corner of the CPU with the small triangle on the board and lower it into place. Apply no pressure, it should just slip in. Now just lower the metal arm back down in the reverse order, and now you have successfully installed your CPU and we can move on to the cooler. Before we install the cooler, we need to remove these two pieces of plastic by removing these 4 screws, then pull them away. Your cooler should have thermal paste pre-applied, but mine did not, so I need to apply a pea-sized amount of thermal paste, but again, if your CPU and cooler are new, you can skip this step. With that done, lower the cooler down with the AMD logo facing the DIMM slots, or I/O, lining up the screws on the cooler with the standoffs on the back plate. Screw each corner in a few turns at a time in a cross pattern until it's secure. Now this next step is optional, but if you want the Ryzen logo on the cooler to be vertical like this, then all you have to do is remove 4 little screws that look like this, rotate the cooler, then reinstall those same screws. This takes 1 or 2 minutes and I think it helps looks a lot. Next, take the CPU fan cable and locate the gray CPU fan connector on the motherboard. Line up the notches on both and lower the connector into place. You can now take the excess cable length and tuck it under the plastic part of the cooler, which will help things to look a little bit cleaner. With that done, we're ready to move on to the RAM, which is very simple to install. We'll be installing our kit into slots 2 and 4 on the motherboard, which are the gray ones. Open the clips at both ends of each DIMM slot. Take your first stick of RAM and line the notch in the stick with the notch in the slot and lower it down. Once you're sure it's in correctly, apply pressure to both ends of the stick until it clicks into place and the clip snaps shut. Now just repeat this process with the second stick of RAM and your memory will be successfully installed. Now we'll be installing our M.2 drive. Below the cooler is the M.2 slot that we'll be using, and before you grab your drive, make sure to remove this little screw. Then get your drive and line the notch in the drive with the notch in the slot and insert it at an angle like this. Now you can hinge it down like this and reinstall the small screw which secures the drive into place. With that completed, we're now ready to shift our focus to the case. Push your motherboard to the side, get out and open up your case. A quick tip is to flip the box over and lift the box away from the case instead of trying to lift the case out of the box. Start by hinging out and lifting up on the glass side panel and moving it to the side. Next, remove the 2 thumb screws top and bottom on the back panel. Then you can just pull back on and lift that panel away. I recommend taking the 2 panels and placing them in the case box with the foam while you're building, as this ensures they'll be out of the way and safe while you're assembling your system. You can now take the manual and retrieve the screw bag that is twist tied to the back and which contains all the screws necessary for assembling this PC. Next, as a preemptive measure, we're going to be unscrewing and removing this back shroud and then the 2 middle I/O expansion covers by bending them back and forth until they snap off and can be lifted away. With that done, we now need to prepare the case for our motherboard. Inside of the screw bag, get out 2 standoffs that look like this. These need to be installed into these 2 holes right here. You can a lot of times do these by hand, but using pliers can help, or for me, I use a nut driver that makes things very simple. Once those are in, grab out your I/O shield that came in the motherboard box, orient it like this and lower it to the I/O cutout. Line it up and press in all 4 corners one at a time until the I/O cover is secure and in place. It should look and be oriented like this when it's all done. With that complete, you can now take your motherboard, handling it by the cooler, and lower it into the case at an angle and hinge it down, making sure the I/O lines up with the I/O shield, and you can see the motherboard standoffs beneath the holes. Get 8 motherboard screws from the screw bag that look like this. Now install 1 into each of the corresponding motherboard holes. Order doesn't matter for this, just make sure they're all secure. With that done, we now need to flip the case face down like this. To make installing the power supply easier, we're going to be removing these 2 screws at the bottom of the case right here. Now you can pull up on this drive mount to release it and then lift it away. You can totally reinstall this once the power supply is in, but removing it now is necessary to get the power supply in place. With that done, you can flip the case onto its feet and get out your power supply. Other than the default cables on the unit, all we need to add is 1 SATA power cable that looks like this, and if your card has more than 1 8-pin header, then add 1 PCIe power cable that looks like this. Just take the 6-pin end of the SATA power cable and pick one of the 3 ports labeled SATA, orient the clip towards the SATA text and press it into place. Now do the same with the 8-pin end of the PCIe connector into one of the free PCIe headers on the back of the power supply. With that done, you can take the power supply with the fan facing down and push it into the back of the case like this, making sure the holes line up at the back. Now take the 4 screws from the screw bag that look like this and install 1 into each of the holes at the back, which makes sure the power supply is secure. We're now ready to start routing cables. Start by taking the large 24-pin cable that looks like this and pushing it through this hole here. Take the 2 PCIe power cables that look like this and push them through this opening here. Next, take the 8-pin CPU power cable and push it through the hole at the top of the case right here. Now take the blue tipped USB 3 cable that looks like this and push it through the cutout located right here. Now grab all the little front panel connectors that look like this. You can see one of them is connected to the fan LED controller. You can separate this cable from the others by just peeling it away like this. Now push the other ones through that same hole that you just used for USB 3. Finally, take the HD audio cable and push it through the cutout right here. With that done, we can put the case onto its side and start plugging things in. Starting in the top left, locate the 8-pin CPU header. take the 8-pin CPU cable and line the clip on the cable with the bump out on the header and press it into place. Now on the right side of the motherboard, locate the 24-pin header, take the 24-pin cable, making sure the two pieces are pushed together, and line the clip on the cable with the bump out on the header and press it into place. With that done, we can move our attention to the bottom of the motherboard. Starting at the bottom left, locate the F audio header, take your HD audio cable with the text facing down, line it up to the header and press it into place. Next, we're going to get the pesky front panel connectors out of the way. Start by grabbing the power LED plus and minus cables. With the positive to the left, press these into the top left pins on the header that look like this. Now grab the HD LED and again with the positive to the left, press it into the two pins directly below the power LED. Finally, take the power switch cable and plug it in directly to the right of the power LED. Orientation doesn't matter. With that done, it means it's time to install our graphics card. If you didn't buy one that's 300+ like I did, then it should be as easy as opening the PCIe lock at the top slot, grabbing your card and lining up the notch in the card with the notch in the slot, then pressing it into place. For me, I had to do a lot of finagling to get it to fit, but in the end I made it work. Now with your card in, you can take two screws that look like this and use them to secure the GPU into place. You can also now reinstall that little cover we removed earlier. Now grab your PCIe power cables and bring them to the power headers on the card. Line the clips on the cable with the bump outs on the headers and press them into place one at a time. With that done, we can flip the case onto its feet to plug in one final thing. Take the RGB fan controller and locate the SATA power connector on it. Now grab one of the corresponding SATA connectors on the power supply SATA power cable. Make sure they're oriented correctly and press them together. With that done, everything has been successfully installed, but there's one last thing to do before we can put the panels back on, and that is cable manage the system. To do this, pull any excess cable link to the back of the case and secure it down with the included zip ties, making sure everything is flat enough for the back panel to go back on. One other thing to make sure is that there are no cables in the path of the GPU fan blades. You can even plug in and turn on the system before putting the panels back on to make sure the fans are spinning freely. Once cable management is done, it means we can throw the panels back onto the case and get to the software side of things. The first is to install Windows. To do this, you need another PC and a USB flash drive that's wiped and has at least 8 GB of capacity. Go to the Microsoft page linked in the description and download the Windows Media Creation tool. Open this up and let it run until you get to this screen. Accept the agreement, then it'll bring you to this what you want to do window and just select create installation media and hit next. Now you'll select some language and version options. Make sure to select your language of choice, Windows 10 and 64-bit, and then press next. Now under choose which media to use, select USB flash drive and hit next. Now select your flash drive, which all data will be erased from, so make sure it doesn't have anything important on it. Once selected, hit next. It will now download the Windows 10 files to the flash drive. Once this is done, you can hit finish and eject the drive. Take it to your new PC and plug it into one of the USB 3 ports on the back. Turn on your PC and it should automatically have this spinning wheel at the bottom and boot to this screen. But if it doesn't do that, boot in the BIOS by turning the PC off, then as soon as you turn it on, start mashing the delete key. Tab over to exit and select force boot to the USB drive. This should then bring you to this screen. Hit next, then hit install now. It will ask you for a key now, which you can get a cheap one from somewhere like SCD Keys, or you can just select I don't have one, which just means you'll have a little activate Windows watermark and fewer customization settings, but everything else is exactly the same when compared to the activated version. Once this is done, you can accept this agreement and hit next. If you don't have a product key, then you'll be asked to select your version, which I recommend Windows 10 Pro. Now select custom Windows install. Now select drive 0 and hit next. It will now go through and install Windows. When this is done, it'll bring you to this page where you will go through the prompts to set up your account and select whatever you want from these options. After that, it will do some more installations and then bring you into Windows. So Windows is successfully installed, but we need to do a few more things before you can start gaming. The first is to install the drivers. For the chipset drivers, head to the link in the description, scroll down, select chipset, socket AM4, then B550, hit submit, select Windows 10 64-bit, and download the latest version. Once downloaded, open it up and let it do its thing for a few minutes until it brings you to this screen where you just press install and let it install the drivers. Once done, you can restart the system and then head to the graphics driver link in the description. There will be a link for both GTX 970 NVIDIA drivers and R9 290/390 AMD drivers. Find and download the drivers that correspond to the GPU you have. Once downloaded, open them up, follow the prompts, and once installed, reboot the system and make sure everything seems to be operating normal with the system. If everything is good, we can start to do stuff with the BIOS. The first is to update the BIOS for full support of our APU. There will be a link to the standard edition of the motherboard and the Wi-Fi version of this motherboard. Select the one you purchased and head to that link. On the support page, select BIOS, then download the latest BIOS available for the board. Open the zipped file, select extract all and extract the files. Take the .14d file and copy it to a flash drive. You can now power down the system and plug in your flash drive to the back of the motherboard. To get into the BIOS, turn the system on, then immediately start smashing the delete key until you enter into this page right here. On the easy mode, select Q Flash, select the BIOS file on your flash drive and select to flash it. Make sure not to power down the system while this is flashing, as losing power to the system while the BIOS is updating has a high chance to break the motherboard, rendering it useless. With that done, you can reboot your system and re-enter into the BIOS. Now head to the tweaker tab under advanced mode and go to extreme memory profile, select that and enable XMP profile 1. Finally and optionally, you can go to the settings tab, go to AMD overclocking and enable precision boost overdrive, which will essentially auto overclock your CPU. With that done, you can restart your system, head into Windows and begin downloading and enjoying some games. So now is time to talk about gaming performance, streaming performance, and temps. I tested 7 different games with varying levels of performance to give you a good understanding of how this system performs in a number of different scenarios. Let's start things off with the ever popular Fortnite, which I tested at 1080p Pro settings, which is epic view distance, high textures, and pretty much everything else set on low. I hopped into a Team Rumbles match, which has a lot of intense combat and is kind of a worst case scenario. Over the course of the match, the system output a 160 FPS average with 1% lows of 48. This is a smooth and enjoyable experience. The 1% lows were low relative to how high the average was, but that is kinda to be expected with Fortnite. The next game tested was a difficult to run AAA game, Borderlands 3. I tested this game at 1080p medium settings using the built-in benchmark. Doing this resulted in a 67 FPS average and 1% lows of 57. This was pretty good performance and is nice to see this PC can run a game like Borderlands 3 at over 60 FPS. Next up is Valorant, which is an easy to run esports game. I tested this at the 1080p high settings it defaulted me to. Hopping into a game, I saw an average of 212 and 1% lows of 138. This was pretty good performance and should be good enough for casual and competitive play. Next up is Genshin Impact, which a lot of you have requested in the past. For some reason, Genshin caps the FPS at 60, and I couldn't find a way to uncap it. In game at 1080p high, I saw a locked 60 FPS, but it would have been nice to see how high this machine could have pushed the frame rates. So if you're wanting to play Genshin Impact, this system is more than powerful enough. Next up is Rainbow Six Siege, which I tested at 1080p very high settings using the built-in benchmark. Doing this resulted in a 203 FPS average with 1% lows of 151, which is great performance in my opinion. In Apex Legends, I tested at 1080p high settings and saw an average of 88 and 1% lows of 59. This was pretty good performance and you could push the average up a fair amount if you're willing to drop some of the graphics settings. Lastly, for the final boss of the benchmark section, I decided to test Cyberpunk 2077, which is horribly unoptimized and very difficult to run. I tested at 1080p low and just drove around at a fast speed to test. Doing this resulted in a 53 FPS average with 1% lows of 42. It's definitely disappointing to see the average below 60, but this was kind of be expected going into this test. Overall, gaming performance is really good. You can play pretty much any game you throw at it, even modern AAA titles. While I recommend upgrading to something like a 3060 when prices normalize, the R9 390 is really all that you need. So now let's talk about streaming. I tested streaming Fortnite to Twitch at 1080p 60 FPS with a 6000 kilobits per second bitrate. I locked the frame rate in Fortnite to 60 and saw a very smooth experience on both my end and the stream end. In terms of temps, I saw both the CPU and GPU range from about 65 to 80 degrees depending on the game. These temps are perfectly fine, and this system doesn't need to get very loud by ramping up the fans to keep the system at these temps. All in all, for $750, you're getting a system that you can build yourself and one that should outperform any pre-built at this price. It's also very upgradable and customizable. These build guides are a lot of work, but if you guys keep watching them, then I will keep making them. So yeah guys, I think this wraps this video up. I hope you guys enjoyed it. If you did, make sure to give it a thumbs up and consider subscribing. And as always, this is Matt from Tech by Matt, signing out.